Welcome to Two Projects. In this video, we are going to explain the project Fake Logo Detection using Deep Learning. Let me give you an introduction to the project first. So, as we all know, fake logos are unauthorized copies of real brand logos. They are created to trick consumers into believing they are buying products from a reputable brand when in fact they're purchasing counterfeit goods. These logos are meticulously designed to closely resemble the genuine logos, often using similar colors, fonts, and overall design elements. The presence of fake logos can have several effects. Firstly, they deceive consumers who may unknowingly purchase inferior or potentially dangerous products, thinking they are genuine. This not only harms the consumer experience but also damages the reputation of the legitimate brand whose identity has been exploited. And financially, businesses suffer from lost sales and may incur costs associated with combating counterfeiting. So, this project aims to combat the spread of fake logos by developing an advanced system capable of both classifying and detecting them automatically. This means the system will not only determine whether a logo is genuine or fake, but also locate these logos within images. So, deep learning techniques are used to analyze the complex visual features of logos. These networks are trained on large datasets of authentic, that is genuine, and counterfeit, that is fake logos, to learn the distinguishing characteristics between them. By analyzing factors such as shape, color, and texture, deep learning models can accurately classify whether a logo is genuine or fake. And YOLO, that is, you only look once model, is used to swiftly and precisely locate logos within images. So, here are a few examples. I have both genuine and fake logos here. We can see they are very similar with minute differences. This is the genuine logo of BMW, this is the fake one. This is the genuine logo of LG, this is the fake logo. This is the genuine logo of Starbucks, this is the counterfeit logo. And this is the genuine logo of Burger King, this is the fake one. They are very similar, so people without knowledge can easily mistake the fake ones for genuine logos. So, detecting the fake ones is very important. Now, we look at the objectives of the project. We aim to create an advanced automated system that can accurately classify and detect fake logos. So, this system will determine if logos are genuine or counterfeit and locate them within images, ensuring high precision and efficiency for applications. For this, we leverage deep learning techniques, specifically convolutional neural network and the exception model, to classify logos based on visual features. For detection, we use the YOLO V5 X6 model, known for its speed and accuracy, to quickly identify logos in images. And to ensure the system is user friendly, we will deploy these models using Flask for easy access and interaction. In addition to standard pre-processing techniques like normalization and augmentation, we utilize advanced image processing methods that are shaping, seam carving, and edge detection. These techniques improve the accuracy and robustness of our classification system. Overall, the system aims to help consumers avoid counterfeit products, ensuring they receive genuine goods. It also protects brand reputations by identifying fake logos and supports businesses in mitigating financial losses due to counterfeiting, providing tools to combat fraudulent activities effectively. These are the objectives. Now we look at the software and hardware requirements to execute this project. Software requirements are: software used is Anaconda, Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database required is SQLite 3 and front-end technologies used are HTML, CSS, JavaScript and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we look at the working modules of law of work. So the first step is importing required packages. So we begin the project by importing essential libraries such as TensorFlow for deep learning tasks, Keras for building neural networks, NumPy for numerical operations, Pandas for dataset handling, and many more packages. So these packages provide foundational tools necessary for data manipulation, model development, and evaluation within our project. The second step is exploring the dataset. So the dataset which we have used in this project comprises original logo images from various brands captured from different angles, alongside manipulated images simulating counterfeit logos or fake logos through grayscale conversion or other alterations. So this diverse data set enables comprehensive training of our models to distinguish between genuine and fake logos accurately. The third step is data processing. Using the image data generator from Keras, we pre-process images by rescaling pixel values and applying augmentation techniques like sharing, zooming, and horizontal flipping. These transformations enhance the variability and robustness of our training data, improving the model's ability to generalize to unseen images. The next step is training and building the models. So we developed two key models for logo classification, a CNN model that is convolutional neural network and the exception model. Training involves optimizing these models on the augmented dataset and comparing their performance metrics to determine the most effective approach for logo classification. After this, the next step is advanced image processing. In addition to standard pre-processing, we employ advanced image manipulation techniques such as shaping, seam carving, and edge detection. So, shaping adjusts the aspect ratio of logo images to standardize their dimensions, making them easier to compare. Coming to seam carving, it optimizes images by removing non-essential, that is, unimportant pixels while preserving important features, ensuring that the critical aspects of logos are maintained during resizing. While edge detection highlights the outlines and structural details within logos, enhancing the model's ability to extract meaningful features that distinguish between genuine and counterfeit logos. So the next comes object detection with YOLO. Here we load the pre-trained YOLO V5 X6 model. We optimize its performance by giving the logos dataset for logo detection. So we implement logo detection capabilities. In the next step, for deployment and user interaction, we integrate our best performing classification and detection models into a Flask web application. This framework facilitates seamless interaction with users. The inclusion of SQLite ensures secure user management with functionalities like sign up and sign in, enhancing the application's usability and accessibility. So, after signing in, users can upload an image for both classification and detection. For classification, they can also select the desired image processing method, that is, shaping or seam carving or edge detection. The uploaded image is pre processed according to the selected method. For classification, for detection, The image is prepared to be analyzed directly by the YOLO V5X6 model. The pre-processed image is passed through the trained models. For classification, the model predict whether the logo is genuine or fake. For detection, YOLO V5X6 identifies and locates logos within the image. So the final results, including classification and detection outcomes, are presented to the user through a user-friendly web interface, providing clear and actionable insights. So this is the workflow. Now we'll look at the algorithms built. First, we'll see the classification models. So we have trained two models for classifications, a traditional CNN model, that is convolutional neural network, and a exception model. So we have trained them and we have compared their performances using different performance metrics like accuracy, precision, recall, and F1 score. And we have observed that the exception model has outperformed the CNN model in all the performance metrics. So we have deployed the exception model into the Flask web application. Now we'll know about the exception model. Before knowing about the exception model, we should know about the CNN model. So CNNs are deep learning models designed for image processing. They use layers, hidden layers that learn patterns and features from images, making them effective for tasks like image classification and recognition. Exception is an advanced variant of the CNN architecture. It is the variant of the CNN architecture. So, exception stands for extreme inception. It aims to improve upon the inception model's efficiency and performance. The key innovation in exception is its use of depthwise separable convolutions, which break down standard convolutions into separate depthwise and pointwise convolutions. So, this separation reduces computational complexity while maintaining or even improving accuracy compared to traditional CNNs. So, this is about the exception model. These are the classification models built. Now, we'll look at the detection. Initially, our project focused solely on logo classification. Later, we extended its scope by integrating logo detection capabilities. So, this extension enhances the project's utility by enabling identification and localization of logos within images. So, the detection algorithm which we have used is YOLO. YOLO divides the image into a grid and predicts bounding boxes and class probabilities for each grid cell simultaneously. Its architecture consists of convolutional layers followed by detection layers that output bounding box coordinates and class predictions directly. YOLO V5X6 is an improved version of the YOLO model. The V5X6 denotes that it is a part of the YOLO V5 series, where 5 indicates the generation and X6 denotes the model size or complexity level. YOLO V5X6 incorporates advancements such as deeper networks, additional layers for improved feature extraction, and optimizations in training methodologies. So it excels in scenarios where rapid and accurate detection of objects is crucial. So this is about the algorithms built. Now we'll see the execution. So before execution, first we need to open the code folder which contains the project's source code files. So this is the code folder and these are the contents I have in the code folder. This is dataset folder in which I have three subfolders: fake, original, and output folders. In original folder, I have these original logo images from various brands captured from different angles. In fake images folder, I have manipulated images manipulated through grayscale conversion or other alterations. So we have manipulated original logo images to simulate counterfeit logos. So before training the models on the images from fake and original folders, so we have split the images from these two folders into train and validation sets. So we have stored the train and validation sets in this output folder. Train set is for training the models and validation set is for evaluating the model's performance. This is about the data set. This is model folder in which I have model files. This is also a model file. So these model files contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is static folder which comprises files related to front end. So it consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is test images folder in which I have test cases which will be used during the execution of the project. This is app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. So these are notebook Jupyter source files. So these files contain a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is notebook file for classification and this is Jupyter Notebook file for detection. And this is signup.db file. So this file is the database file used to store user information. It stores information like user signup details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path of the code folder and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. So this is the local host and this is the port. Now copy the local link provided by the Flask framework. I'm copying it and paste it into any web browser. I usually prefer Google Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So by clicking on these dots, we can see a sign up link here. Click on it. So if you are new to the system, we have to register ourselves first, fill in all these details and click on register button to sign up. If we already have an account, we can directly log in by clicking on this link. As I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the classifications page. As a default, we were redirected to this classification page. If we want to perform detection first, we can do that by clicking on this detection dot. We can see I have four dots here: classification, detection, about, and sign out dots. So by clicking on this dot, we can go to the detection page. And I have the links here: classification, detection, and sign out. We can use these links also. First, we'll perform classification task only. So before uploading an image here, we have to select the processing method from this drop down, whether it is seam carving method or edge detection method or shaping. So the uploaded image will be processed according to the selected method, and the pre-processed image will be input to the exception model. By clicking on this upload button, the exception model will make the predictions, make the classifications if the uploaded image is real or fake. So the processing method I'm choosing is shaping. Click on choose file. From test images folder, these are the test cases I have. I'm selecting this image and click on open. The image has been loaded. Now click on upload button. So this is the uploaded image. And here we can see the result given by the exception model, that is fake logo. So the exception model has analyzed the pre-processed image. The uploaded image has been pre-processed using the shaping method. The exception model has analyzed the image and given us this result, that this logo is a fake logo. We'll try again. Click on try again link. This time processing method would be edge detection. Click on choose file. This time I'm selecting this image and click on open. Now click on upload button. So this is the uploaded image. This is edge detected image. So this is the result, the classification made by the exception model. So the application has classified this logo as a original logo. It is the real logo. So this image has been taken from different angle. This is the original image's edge detected image, and this is the result. We'll try again. Click on the try again link. We'll try giving another image. So this time processing method would be seam carving. Click on choose file. So this time I'm selecting this image and click on open. Now click on upload button. So this is the uploaded image, the original image, and this is seam carved image, the pre-processed image using seam carving method, and this is the classification made by the exception model, that is original logo. So the application has classified this logo as a original logo. Click on try again link. So in this way we have to select the processing method, select the image, click on upload and get the results. So processing method would be seam carving again. Click on choose file. This time I'm selecting this image. Select the image and click on open. Now click on upload button. This is the uploaded logo. This is the seam carved image of the original image, as we have selected the processing method as seam carving. And this is the result given by the exception model. So the exception model has analyzed the same carved image and given us this result that this logo is a original logo. Click on try again. We'll try with some more test cases. Processing method this time would be edge detection. Click on choose file. I am selecting this image and click on open. Now click on upload button. This is the uploaded image. This is the edge detected image as we have chosen the processing method as edge detection. And here we can see the result, that is fake logo. So the application has classified the logo which we have uploaded as a fake logo. It is not a genuine one. Click on try again. Processing method would be shaping. Click on choose file. I am selecting this logo. Click on open. Click on upload button. This is the uploaded image. And here we can see the prediction, that is it is an original logo. So the exception model has classified this logo as a original logo. Click on try again. Processing method this time would be seam carving. Click on choose file. We'll try with this one. Select the image and click on open. Now click on upload button. This is the image which I have uploaded, and this is the seam carved image, the processed image. This processed image will be input to exception model, and the exception model has given us this result, that is original logo. So the application has classified this logo as a original logo. It is a genuine one. Click on try again. Processing method would be edge detection. Click on choose file. This time I'm selecting this one. Click on open. Click on upload button. This is the uploaded image. This is the edge detected image. This processed image will be input to exception model, and the exception model has given us this result, that is fake logo. So the application has classified this logo as a fake logo. Click on try again. We'll try with one last image. Processing method this time would be shaping. Click on choose file. We'll try with this one. Select the image and click on open and click on upload button. This is the uploaded image. This is some part of a logo. And here we can see it is a original logo. So in this way, we have to select the processing method, upload an image and get the results. Now we'll see detection. Click on this dot. So we are redirected to the detection page. We have to upload an image to get the detection results. Click on choose file. Select any image. I'm selecting this one and click on open. The image has been loaded. Now click on upload button. So we can see the application has drawn a bounding box around the detected logo from the image. So we can see the bounding box here. And we can see the class label, that is fake. So the application has classified this logo as a fake logo. We can see the class label. And beside the class label, we can see a probability score, which tells us how confident the application is in classifying this logo as a fake logo. Click on back, click on choose file. We'll try giving another image. We'll try with this one. Select the image and click on open. Now click on upload button. So we can see the application has drawn a bounding box around the detected logo, and it has classified this detected logo as a original logo. So beside the class label, we can see the probability score, which tells us the confidence level of the application in classifying this logo as a original logo. Click on back, click on choose file. We'll try with this one. Select the image, click on open. The image has been loaded. Now click on upload button. So we can see the bounding box drawn around the detected logo, and we can see it is a fake logo with this probability score. So the application is 73% confident that this is a fake logo. Click on back, click on choose file. We'll try with this one. We can see the bounding box drawn around the detected logo in the image, and we can see the class label here. The application has classified this detected logo as a fake logo, and we can see the probability score. Click on back, click on choose file. We'll try with this one. So we can see the application has detected the original logo. It has drawn a bounding box around the detected logo, and we can see the class label here. Beside the label, we can see the probability score, which tells us the application is 77% confident that this logo is a original logo. Click on back. So in this way, we have to choose file and upload upload the image, and the application will detect the logo from the image. Click on choose file, select the image. I'm selecting this one. Click on open, click on upload. So we can see the application has detected the logo from the image. We can see the bounding box drawn around the detection. We can see the class label and the probability score. Click on back. So in this way, we can perform the detection task. Now we'll look at the graphs plotted. Click on the about dot here. So this is a horizontal bar graph comparing accuracy scores of exception and CNN models. So in this graph on x-axis, I have accuracy scores, and on y-axis, I have algorithm names. So accuracy measures how often the model predicts correctly. It is the ratio of correct predictions to the total predictions made. We can see exception model is doing well. This is precision scores comparison graph. So in this graph on x-axis, I have precision scores, and on y-axis, I have algorithm names. Precision indicates how precise the model is when it predicts positive instances. It is the ratio of true positives to all predicted positives. Similarly, this is recall scores comparison graph. Recall measures the model's ability to find all positive instances. It is the ratio of true positives to all actual positives. And this is F1 scores comparison graph. So F1 score combines precision and recall into a single metric. It is a harmonic mean of precision and recall, giving a balanced measure of a model's performance. So we can see exception model is doing well in all the performance metrics. Now click on sign out. So in conclusion, we have developed a system capable of automatically detecting and classifying fake logos addressing a critical need in consumer protection and brand integrity. They started with logo classification and later expanded to include logo detection, enhancing the project's capabilities. So we employed advanced deep learning techniques and deployed algorithms like exception for classification and YOLO V5 for logo detection. Detecting counterfeit logos is very important in safeguarding consumers from fraudulent products and protecting brand reputations. Our system enhances accuracy and efficiency in distinguishing between genuine and fake logos, thereby mitigating economic losses and preserving consumer trust. So, beyond basic image processing, we utilized advanced techniques such as shaping, seam carving, and edge detection. These methods improved our model's feature extraction capabilities, ensuring robust performance in identifying subtle visual differences between authentic and counterfeit logos. The integration of our models into a Flask web application with SQLite database support enables user friendly interaction. Users can upload images for classification, select processing methods, and promptly receive results. Overall, the beneficiaries of our project include consumers seeking genuine products, businesses aiming to protect their brand integrity, and regulatory authorities combating counterfeit trade.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.